So I'm delighted to be here today in Geoff Faux's house with him. Geoff is my mentor over many years now, and he's the architect of all the great practice that I've been picking up in Cumbria. Geoff was the county advisor for maths for Cumbria from
1974, well, 72 in Cumberland, which was a different place, and then 74 to 93.
And lots of the great people I've worked with are directly influenced by Geoff. I used to take them away on courses for several days and ponder mathematics education in great detail, and just an amazing geometer of maths, and all that's here, and all the equipment that you bought I was picking up in schools and digging out again. So Geoff has refused to tell me what this interview is about. I'm just going to hand over to him.
Thanks, Rebecca. When Rebecca rang me and said she wanted an interview, I thought, I'm really past all this and I wouldn't bother. Anyway, nothing is not a big nag. So she then turns up through the motorway chaos, and here we are. What I said to her was that I wanted to talk about chalk and talk. Now, if you think of chalk and talk as a phrase, it's almost a term of abuse for teachers. They're all chalk and talk. And I wondered where it had come from. I picked up that there was actually, before the Second World War, some visits to Europe to see what was going on in maths education in various bits of Europe. One of the things that came back from the Austria-Hungary bit was they do a lot of chalk and talk. And I luckily, somewhat later, was able to go and work in Hungary for a short period of time and discovered that actually it's not, the meaning of words are always difficult to get hold of, but the meaning of these two words were quite different. And sitting in classes in Hungary, you discover that the chalk in a good lesson is held by the children, or often one child, who is at the board writing, maybe solving an equation, or maybe working at something else. And the talk is by the teacher who's providing the language to try and clarify for the rest of the class what it is the child with the chalk is doing and hopefully even thinking. And this, when it works, is incredibly powerful.
I assumed it was a teacher standing at the front.
No, the teacher does not have the chalk. So what's given away is the power of ownership. Mm. And that is a very powerful thing. But of course, as a teacher, you have to have the confidence that you have at your fingertips what is going on in the room, and that you have, your job is certainly to provide the language.
And that can be really difficult
yes,
if you've not come across the method a child's trying to use.
Yes, but also you can insert words that you want to be in the vocabulary of the class carefully in the context that you are providing. Now, I thought I would perhaps like to work with something as a task. Can we have it on the screen?
Yeah, I'll just share the screen now. Okay.
Right. So I'm taking an idea I once first saw John Mason do in a lesson where he was working, not with chalk and talk at all, but with specializing and generalizing. So this question was put up: 2 + 2 = 2 times 2. We think about that. That seems to be true. And the question to the class was, if that's true, are there any other possible ways of writing 2 numbers down, adding them, and if you multiply them, you get the same answer? Do you want to work on that, Rebecca?
Well, my instinct would be no.
That's okay. Well, what I would actually like to offer you, on the next line, can you write?
Write or type?
Type.
Okay.
3 plus 1.5.
Can I write 1.5 or do you want me to?
1.5. If you put 1 and then 1 slash 2, it will type it.
Okay. Yeah.
Equals 3 times 1.
Right. Just reduce the size of that a little. I'll edit this a bit so it'll go straight to.
Exactly. So I'm now going to offer you 3 plus 1.5 is the same as 3 times 1.5. Now, is that true? And I might want, certainly if I had a class as opposed to you, I would want the students to be working on that.
Wow.
The first one on the left is quite easy. Many, many people can add 3 plus 1.5 to get 4.5. But 3 lots of 1.5, which a lot of students have worked with, that's the first place at which they will fall. If I'm in Hungary, I will very likely ask a student to write on the board how she has got that 3 times 1.5 and get them to write out the fraction multiplication, and then I can comment on it as it occurs. Okay? Yeah. So we've got 2 plus 2 is 2 times 2. And the next one we have is 3 plus 1.5 is 3 times 1.5. So we have 2. Could we possibly think what the next one is on that list? Would you like to conjecture one for me, Rebecca?
No, I feel really thrown. That's just put me totally out my comfort zone, Geoff. I thought I knew what I was doing.
Okay.
So
wow. We've gone from 2 to 3. And if we stick with the other one, 3 plus 2 and 3 times 2, well, 3 plus 2 is 5 and 3 times 2 is 6. But now 3 lots of 1.5 is 4.5, and 3 times 1.5 is also 4.5. So I want really to think about what do we notice? What patterns do we notice in what we've done there?
So we've gone from 2 to 3.
Yes.
So I suspect it might be nice to try 4 next.
Seems a very good idea. 4 plus something is the same as 4 times something.
Now that second number has gone down. The 2 has gone down to 1.5.
Yes.
Now if we did 4 add 1, and 4 times 1, that'd be 5 and 4.
Yes. So we need 4, 1 and a bit.
Yeah.
Now with the 3, we got a half.
Right.
So we're trying to spot a pattern here. We're trying to spot a pattern. And that, with a class, I would want some discussion. But I think at this point, I might want 3 plus 1 1/3. Can you type that for me? 4 plus 1 1/3.
Just leave that as a large fraction.
You have to. Okay. Now, this is 4 plus 1 and a third is the easy one. It's 5 and a third. But what's 4 lots of 1 and a third? And I would actually want this written by one of the students in the class on the blackboard and see how they worked on it. And that would enable me to insert, if I needed to, 1 and a third is it's 3/3 of 1, it's 4/3. So it's 4 lots of 4/3, for instance. I don't know if that will happen or not.
Well, I've been doing questions like this with a year 6 group in the last few weeks.
Right.
And when in my video on multiplying fractions, I recommend doing it with squares and grids and array.
Okay.
And I recommend doing questions like this on the way there.
Yes.
As part of that year 6 topic.
Absolutely.
And so I've been doing that in practice. It's worked really well. Children became confident with these when they drew rectangles that were 4 squares long and 1 1/3 squares high.
Yes, because you've got the little bits to add on. It
took a bit of brain work, but they were really getting the hang of why the answer was 5 1/3.
So the geometry behind that is very nice.
Yeah, it is.
So what we're trying to do at the moment is work with some special cases which happen to be true. I've taken 2 numbers, the 2, add 2, and 2 times 2, and then 3, and you are quite nicely writing 5 plus 1 and something.
Well, I'm just trying to follow the pattern. I don't know if this works or not.
You have a pattern, and we could work there, and that's really nice that this particular machine is able to do quarters, but draws the line at thirds.
So 5 times, oh, I've missed the 1 out there. Let's just pop that in. 5 times 1 1/4 is going to be 6 1/4.
Yes.
Oh, so it works.
Yes, and 1 1/4, I think, is 5 quarters, and it's 25 quarters, which is happy. So we've done that very nicely. And but in a way, mathematics is always about trying to go for the general. And we have specialized, and I noticed that you took very happily the pattern from the 3 to the 4 and went straight to the 5. So if we go on, can we go on the next line?
Yeah.
12.
Ah, no, can't cope with 12.
12 plus something.
1 and an 11th.
You reckon?
Oh, that's confusing to read. 12 plus 1 and an 11.
Yes, we need to deal with the typing. It's because we're working just on ourselves.
Just put a bigger gap there.
Yeah. Okay, that's
12 times 1 and an 11th.
Yep.
Oh dear. Pull that in. There we go. Now, is it true? So we've got 1 12 and we've got 12 11ths. So that's 13 and 1 11th on the left.
Yes.
And oh no, sorry, I've just worked out the right. So it does work.
It does work. It does work. So that's absolutely fine. But in some ways, I'm now quite free to decide where I go next and what I'm going to offer to the whole class. And I need to know the class because there's many ways I could go from here.
What have you got in mind? I mean, obviously there's the AB generalization.
Well, I could, or XY or AB. So, or I could, it was very interesting that when I went from 5 to 12, you said, and that's absolutely okay, because you feel very confident with the 2, 3, 4, 5. But I just took a little gap along. But if I put -4 or a half,
Oh no!
If I put a half down, what's the fraction that goes after a half? A half plus something is a half times something. And that is a way forward, but all the time I'm trying to push for the generalization. Yes, I love your face, Rebecca.
But I'm also delighted, partly because the maths is as brilliant as you always do, but also because it's just captured what we've been doing for generations here now in Cumbria, because this is the passion that you brought here. And you've got teachers used to being out of their comfort zones themselves with you. So then they were more comfortable being out of their comfort zones with their children in their class, because they were just used to it and they could see how much it helped the whole mathematical learning and the growth as mathematicians.
Yes, so what we might want to do, we've got actually two numbers, and I might at this stage want to call them x and y. And I noticed that x plus y is x times y, and I can write that down as an equation. And if I'm going with perhaps a year 9 or 10, I might want to look at graphing. X plus y is x times y. But with others, I might want to do something quite different. Because, for instance, 2 plus 2 is 2 times 2, and I'm delighted that when I asked for others that might be the same, you didn't offer me 0 plus 0 is 0 times 0. Because although that's true, it's not very helpful on the whole number to fraction route that I hoped we would go down. So there are some things that occur when you give the child the chalk that might be down a route that you don't want to go.
And the other thing that occurs to me is I've just been teaching these mixed year 5-6 classes recently.
Right.
And I had children who were eating everything I gave them for lunch and deeply understanding it immediately. And you could offer them something like this as an extension, and I would set them an initial one and get them to think. And then I would come back and prompt them with this second one, the 3 add 1.5 equals 3 times 1.5. Set them working again individually. The children who are stunningly able, like amazingly individually.
Right. So we might think about -1 times our half and -1 plus a half. So we're suddenly into negative numbers. And -1 plus a half, I think, is minus a half. And -1 times a half is also minus a half. So we have another pair of numbers that meet the criteria. And at what point do we want, as someone knowing the mathematics behind this, do we want to go into either fractions or negative numbers, or horrendously negative fractions?
Mathematically, I think this is the right time to stop, because we'll have lost a lot of the audience. So is there anything else you want to say about the pedagogical side of this?
Well, I think what I want to say is that if you can think about some of the ways we work on our own teaching, a little technique that the Maths Education Unit and the OU had was to ask teachers, having asked a question, to quietly count to 5 before giving the answer in their head. And an alternative to doing that is to give the chalk to a child, and then you have to wait, because it is not productive to say, and now you write this. You want to see what they write, which will tell you so much about where they're thinking. And it's your job in all of this to provide the language. And the language I was able to offer in the little bit we've been talking about is top-heavy fractions, or whatever you want to do. 1 1/3 is 4/3. That equivalent, and I didn't use the word equivalent, but that's really important. I would quite like to show the graph, but I don't know whether we could add that in afterwards.
If you want to,
x plus y is x times y. Anyway, but we'll do that. I think we should stop.
Right. So just before we stop recording, if you draw the graph and just take a screenshot and email it to me.
Yes.
If you just want to record a little bit of voice audio now, and then I can put the visual with your voice in here.
I think there might be a better way of doing it.
What's that?
Okay. I'll send you a little video of it.
With your voice recording, you send me a short video. And if it's a short video, it'll go by WeTransfer and stuff.
Yeah.
Okay.
Right. Let's stop.
Thank you. Stop the share and end recording.
I have a conversation with Rebecca and then think there are things I would like to add. I certainly want to continue with the theme we had, which was about chalk and talk, where in Hungary, where my experience was, the chalk was what the pupils had and the talk was what the teacher provided. Now, we started off with 2 plus 2 is 2 times 2, and I think I forced a lot to go to 3 plus 1.5 is 3 times 1.5. And so we've got there, if we look at the structure, we have two numbers that you can either multiply together or add, and when you do that, you get the same answer. Now, algebra is always a nice thing to do, to use, and what I want to do is think about how can I state that in algebra? Well, I might say if one of the numbers is x and the other number is y, then I can say multiplying them together is the same as adding them. And that's a statement, but it doesn't get me very far because I can't, unless I know one of them, how do I get the other one? But perhaps I could change that as an equation round a little bit so that I can get y in terms of x or even x in terms of y. So if I look at that, I could write x times y minus y is the same as x. Just making sure that if xy is x plus y, then xy, if you take away y, is x plus y minus y. So that's okay. But that's still not what I want, but I now notice I've got xy minus y. Now, it might be really helpful to write that y times 1. Because if I write that like that, then I can see that I can write that equation as y times x minus 1 is the same as x. And if I look at that equation, I could actually divide the left-hand side by the whole bracket, as long as I do that to the right-hand side. So I can write y equals x divided by x minus 1. Now that's quite nice, because if I want to find y now, all I have to do is put in the number for x on the left-hand side. So if I, for instance, put in x is 4, then y equals 4 divided by 4 minus 1. it would be better to put the brackets in. And 4 minus 1 is 3, so y is equal to 4/3. And 4/3 is 1 1/3. That is the number that we got before. But we started there with whole numbers. So if I had x as a fraction, if x was, for instance, 1.5, then what is y? This is the point when, if I was running a class, I would ask some volunteer to come forward and work out what y is when x is 1.5 on the board, because that manipulation of fractions would help me see the understanding in the class. It would also allow other students to put in their tuppence worth to the person who had the chalk. And that in itself, I think, would be a very helpful development. It would not only enable me to see the fraction confidence, but also for the students to work on it as quite a hard problem, assisted by the other students in the class. Continuing the idea that we now have an equation which we got from changing round x times y equals x plus y, and this is on the screen. It is sometimes very helpful when you have an equation to draw the graph. Now, what we know about that particular graph is that it must go through the point 2, 2, the point 3 and 3, 1.5, and so on. This is a GeoGebra screen, and I can, down the bottom, put an input for 2, 2, and that point, when I press return, is the point A, 2, 2. So x is 2 and y is 2. I can also put on 3, 1.5 and see what we get. Well, that's the point B. But not only can I draw these points I've already got, but I can write the equation y equals x divided by open bracket x minus 1 close bracket, and I've found I've got 2 bits of curve. The one we already have with A and B on it, we know what those are. They are 2, 2, 3, 1.5, and the next one will be 4, 1 and a bit less than a half, and so on. But surprisingly, we've got another piece of curve down here. Now, it would be quite useful to put in some 2 straight lines. I'm going to put in y equals 1, and I'm going to put in x equals 1, and I've got those 2 straight lines. Now, the curve here seems to come out and go very closely along, getting closer and closer to y is 1. And this one is getting closer and closer to x is 1. The name of this curve is a rectangular hyperbola. It's called a rectangular one because the axes are at right angles, as you can see. And I could actually, if I want, zoom out and look at what happens. And I think you can see that as I zoom out, the curve gets very, very close, both on the vertical axis and on the horizontal axis. I'll just zoom back in so that we can see it. Go one more in, and what I need to do now is move the graph so that it comes back where we had it. There we have it. Now, if I put one little point on here, then I can move that point onto this other piece of curve. We notice there that I put it at 0, 0. It is obviously true that 0 plus 0 is the same as 0 times 0, one that we had not perhaps thought about before. But if we have move it along a little bit to -1, I've very carefully tried to do that. -1, and the other one is a half. Now, is it true that -1 times a half is the same as -1 plus a half? I will leave that with you and further work to work on.